So for this video, this is number 4 in the series. Up to this point, we've discussed what it means to the definition of relation and function, what they look like in the real world, and how we kind of can use the real world as examples of which is which. And then we also took a look at some examples using a coordinate plane and discussing points in the domain and the range of that. We also introduced in the third video the vertical line test as a way to determine whether or not a relation is a function. So all 4 of these colors here represent relations on the coordinate plane. Whether or not they're a function, we still have yet to determine. If we take a look at each one as a color, then we can discuss them individually. Taking the first one, let's take the purple as the first one. And so if we're taking a look at this purple function here, or what we hope is a function, because that's the coolest. If we take a look at the purple one here, we notice that, oh, well, it tends to repeat itself over and over and over again. And for those of you familiar with trigonometry, you might view this as the approximation to the sine function. That's perfectly fine. If you didn't see that, that's perfectly fine too. Take a look at each piece of it, though, and again, I recommend taking a pen or a pencil, a piece of paper, something, and gliding it vertically over your graph. So I'm sliding this thing from left to right. And I'm noticing that no matter where I place my pen as it's vertical, nowhere does it touch more than once. Because of that, it doesn't violate that definition of function. So the purple is a function. It's my poor approximation to the sine function. If we take a look at the green one here, this, as I sweep, is also a function. At no point does this vertical line ever cut more than once through the green. Now, it looks like it ends. It does not. It actually continues both left and right and up and down. The problem is, of course, is that we can't show the entire function because it's infinite. It's both infinite in not only x and y, but not only in x but also in y. So there's no way I could zoom out far enough. So the arrows say it's going to continue on in that direction forever and for always. It's hard to explain that with the sine function here, just because it's kind of hard to say, hey, this squiggly mark, yeah, that goes on forever in that direction. Okay, so this is also a function. It is not, vertical line test does not violate the definition of function, therefore we can call it a function. This may be, for instance, some kind of y equals 3x cubed plus 4x squared minus 5x plus 6. I'm sure that somebody's going to say, no, that can't be it because the zeros don't match. I get it, but this is, at least a cubic, if not slightly more. It is odd, so the degree on it is odd, but it's at least a cubic. Moving on with the orange. The orange is an ellipse, or what I tried to approximate as an ellipse. And if we were to go through here with our pen, we would notice that striking a vertical line at some point would create 2 different connections. We can't have that. And because the vertical line test fails, this is not a function. It is, however, still a relation. Every graph is a relation, but not every graph is a function. In the red here, again, we can do that by we form this vertical. It's going to touch at least twice at some point along the graph, and so because of that, again, we have this condition that it's not a function, but is a relation. And so that's a way that you could go through and test for functionality. If this is in fact a graph of a function, fantastic. We can put it into our calculators. Life is good. If it's not a graph of a function, we have a distinct issue because our calculator doesn't like things that aren't functions. Don't get hung up on the fact that this is a coordinate plane. It can change, and the definition of a function changes right along with it. So there's a much more general idea of a function, but that's to be learned another day. All right, I am going to then take a look at some special ones in video 5, and that's going to round up our introduction to functions.